Hello friends. Welcome to Gyan Guru official channel. This video is helpful to understand the indoor lighting design terminology such as what is LED, luminous flux, lux, illumination laws, luminous intensity, illuminance, luminous efficacy, color rendering, color temperature, etc. This video is the part 1 of lighting design. To completely understand the lighting design for indoor and outdoor area, you need to explore the other two parts. Other two parts will be covered in separate video in continuation to this video. Part 2 of the video will cover the indoor lighting design, which consists the method for designing the lighting for a particular area and what all factors required to be considered while designing. Part 3 of the video will cover the exterior lighting terminologies and designing and the factor to be considered while designing road lights, compound lighting, etc. All three parts of the video is based on the Indian standard and international standards which we used while designing. After seeing all videos, you will be able to design the indoor and outdoor lighting design. Before starting, don't forget to subscribe our channel and press the bell icon to get the automatic updates whenever we upload the videos. Videos are made with the aftermath of detailed research so that we can provide you the legitimated information based on certain references. At end of the video, we would be happy if you provide that genuine feedback. You must have some question in your mind about the lighting design. Like what actually mean by light, how can it be measured, what is its unit, what is color rendering index and how it helps in selecting the right light for right application, and what all are the applicable standards we need to follow while designing. There are many more questions arising in your mind pertains to the lighting design. Let's start to understand the factors and definitions involved in the lighting design through the terminologies. LEDs are semiconductor diodes, which are electronics devices that permit current to flow in only one direction. The diode is formed by bringing two slightly different materials together to form p-n junction. In a p-n junction, the p-type contains excess positive charges, holes, indicating the absence of electrons, while the n-type contains the excess negative charge, electrons. When a forward voltage is applied to the semiconducting element forming the p-n junction, electrons move from the n area toward the p area and holes move toward the n area. Near the junction, the electrons and holes combines. As this occurs, energy is released in the form of light that is emitted by the LED. Manufacturer's specification provide the maximum reverse voltage is acceptable for LED devices. 5 volt is a typical maximum rating. The process of combination of electrons and holes across the p-n junction causes energy to emit in the form of light, which makes the bulb to lit. That's why we called it LED lights. For measuring the apparent intensity of light as it strikes a surface, we need to understand the luminous flux and lux. Luminous flux is the total light output emitted by a light source, also the total light falling on a surface. Light output of a light source is measured in lumen, and lux is the standard unit of illuminance of a surface being lit. 1 lux is 1 lumen per square meter. You can simply refer the picture in which a light source having 800 lumen means intensity of striking the light on the surface. Its mean 800 lumen light source illuminate the 1 square meter with 800 lux power. This much of lux you will get over 1 square meter. When we measure the lux at 4 square meter, the lux value reduced to 200 lux as surface brightness decreases when light source spread the lux over a larger surface. Do you know, why does light intensity decrease as distance increases? To know the answer of this question, we must understand the laws of illuminations. There are two such laws. First is inverse square law, and second is Lambert's cosine law. By seeing the figure shown in this video, inverse law states that as light radiates from a point source, the intensity of light is inversely proportional to the square of the distance from the source. Which means intensity of light naturally decreases as the distance increases. In the figure, light intensity have maximum value at distance d, which further reduces to 1/4 when distance increases to 2d. After that, when distance increases to 3d, light intensity becomes 1/9 of the original light intensity at d distance. According to this law, illumination varies directly as the cosine of the angle between the normal to the surface and the direction of incident light. In the figure shown here, this source illuminating the normal surface, as per the equation, illumination varies inversely proportional to the height of source and directly proportional to the cosine of the angle between the normal to the surface and the direction of incident light. As the angle of incidence increases from 0 degree to 90 degree, illuminance, or you can say light density falling upon a surface, drops by a factor of cos theta. When there is a 0 degree angle between the normal and incident light, maximum light density we are getting. Upon increasing the incident light angle from 0 to 30 degree, we are getting 87% light density in compared to the maximum light density at 0 degree. Further angle increases to 60 degree, light density further reduces to 50%. In next step, when incident angle increases to 85 degree, the light density becomes the 9%. Hence, we can conclude here the more is the angle of incidence, the less will be the light density or illuminance. Let us figure out the difference between the illuminance and luminance. See the figure, there is a candle as a source of light whose luminous flux is the amount of light coming from a light source. It is measured in lumen. The amount of light that travels in certain directions from the source is called the luminous intensity and is measured in candles. When this amount of light falling on surface is called illuminance, measured in lumen per square meter, that is lux. And there is an observer who seeing the amount of light reflected off a surface called luminance, measured in candela per square meter. Luminous efficacy is a measure of how well a light source produces visible light. It is the ratio of luminous flux to power, measured in lumens per watt in the International System of Units. In other words, the luminous efficacy of a source is the product of how well it converts energy to electromagnetic radiation, and how well the emitted radiation is detected by the human eye. In the figure, you can see wavelengths from 400 to 700 nanometer can only be seen by human eyes. Light outside of the visible spectrum are not useful for illumination because they cannot be seen by the human eye. Let's see the spectrum in next slide for more clarity. The visible light spectrum is the segment of the electromagnetic spectrum that the human eye can view. More simply, this range of wavelengths is called visible light. Typically, the human eye can detect wavelengths from 380 to 700 nanometers. As the full spectrum of visible light travels through a prism, the wavelengths separate into the colors of the rainbow because each color is a different wavelength. Violet has the shortest wavelength, at around 380 nanometers, and red has the longest wavelength, at around 700 nanometers. The spectrum from 380 to 700 nanometers are also known as Vibgyor, as the spectrum started from the violet color, then indigo color, then blue, then green, then yellow, then orange and last, red, at 700 nanometer wavelength. The other waves like radio waves, microwaves, infrared, ultraviolet, X-rays and gamma rays cannot be seen by human eyes. These waves are being utilized in different applications. Now let's understand the color rendering index. Put simply, the color rendering index, CRI, measures the ability of a light source to accurately reproduce the colors of the object it illuminates. CRI represents how good a light is to render the colors when it falls on the object, how true color of that object can be reproduced. See the image shown here. We all know natural light such as sunlight is a combination of all the colors of the visible spectrum. The color of sunlight itself is white, but the color of an object under the sun is determined by the colors that it reflects. Here red apple appears red because it absorbs all colors of the spectrum except red. Only red color wavelength reflected by the apple, due to which apple appears red. When we use an artificial light source such as an LED lamp, we are attempting to reproduce the colors of natural daylight such that objects appear the same as they do under natural daylight. The color rendering index of a light can be measured in a scale from 0 to 100, indicating how accurate a given light source is at rendering color when compared to a reference light source. Lights with a CRI that is measured less than 70 are considered to be poor rendering. In other words, CRI less than 70 means that when light fall on objects it cannot able to distinguish the colors when compared to natural light source. Now if go up in the color rendering index scale, lights with a CRI that is measured greater than 70 but less than 80 can considered good, as the light source capable to render the color as close to the naturally lights. Means light source capable to distinguish the color from 70% to 85% accuracy. Lights with a CRI that is measured greater than 80 is generally considered high CRI lights with the capability of rendering the color similar to the natural light source. See the apple with color rendering index 70 and compare it with color rendering index 97. One can observe the difference in the clarity of color that a light source with CRI value of 97 produces as compared to CRI 70. Similarly, CRI 90 and CRI 80 apple figure, there is not much difference, but CRI 90 produce more accurate color rendering close to the natural light rendering. So we can conclude here that light with high rendering index more than 80 is more preferable, as true color are rendered accurately by the light source close to the natural light's rendering capability. The color temperature of a light source is the temperature of an ideal black body radiator that radiates light of a color comparable to that of the light source. In other words, color temperature is a way to describe the light appearance provided by a light source. It is measured in degrees of Kelvin on a scale from 1000 to 10,000 as seen in the figure. At the lower end of the scale, from 2000 Kelvin to 3000 Kelvin, the light produced is called warm white and ranges from orange to yellow-white in appearance. Color temperatures between 3100 Kelvin and 4500 Kelvin are referred to as cool white or bright white. Light bulbs within this range will emit a more neutral white light and may even have a slightly blue tint. Above 4500 Kelvin brings us into the daylight color temperature of light. Light bulbs with color temperatures of 4500 Kelvin and above will give off a blue-white light that's somewhat similar to the daylight. It is important to know what color temperature you are looking for. The color temperature of a light bulb or an LED fixture describes how the light appears when we look directly at the fixture. Nowadays, LED bulb is dominant. Many designers or customers really enjoy warm tones that match up to incandescent light bulbs which fall into the 2700 Kelvin, 2800 Kelvin range. The LED bulb color temperature from 2700 Kelvin to 2800 Kelvin are commonly used in restaurant lighting, residential lighting, hotel walkways and rooms and spaces where a warm ambience is needed to set the mood. Cool white ranging from 4000 Kelvin to 4300 Kelvin is also very popular in offices and commercial buildings. As you move up in the color temperature scale, you will get some yellows starting to show up and some more bluish white light. As move on the spectrum forward from 5000 Kelvin to 5765 Kelvin, these light looks very white to our eyes, crisp clean looking light that is appealing for modern spaces, paint booths, gas stations, hospitals and office environments. And above 6500 Kelvin, the light will have similar color as that of natural light outside. Daylight gets into the blue spectrum and you start seeing less of the yellows and whites. You will still have what appears to be a bright light, but when compared to full spectrum you can visually see the blue light starting to take over the color of the light. This table gives you a glimpse of application of different color temperature of LED lighting. Like color temperature range from 5000 Kelvin to 10,000 Kelvin are described under daylight or natural light. These lights can be installed for graphic studio, shops, malls etc. And 4000 Kelvin to 5000 Kelvin described under cool white fixtures and can be used in hospitals, manufacturing unit, offices, operational center, server room etc. Lastly, below 4000 Kelvin, the light fixtures are under warm lights and can be used in residential, hotels, supermarkets, city beautification etc. Please note, application of light fixtures based on the color temperature may vary based on the specific requirement of end users. Whatever above said is based on the industrial practice, may not be applicable in few places where customer has specific requirement. Now we have understand the importance of color temperature of light fixtures. But have anyone thought why color temperature measured in Kelvin? Although Kelvin is the unit of temperature, let's understand this in detail. A black body is a theoretical object that absorbs 100% of the radiation that hits it. Therefore it reflects no radiation and appears perfectly black. As the term theoretical indicates, it is an object that can only be confirmed by scientific and mathematical processes. In scientific terms, it is a body that only exists at a temperature of absolute zero, that is minus 273.15 degrees centigrade. This is the temperature at which all molecular motion ceases. Therefore any action placed upon this black body at absolute zero is totally absorbed by the body. In the figure, we have shown soil pot to make you understand the concept. Soil pot has been placed on fire. After a few minutes of putting soil pot on fire, we will observe that the temperature increased from 900 Kelvin to 5500 Kelvin. Upon increase in temperature, color of the pot also get changed. It's mean when any object or light heated, it start glowing just like the soil pot shown in the figure. Upon glowing it start emitting the color like red at particular temperature. Hence, we can say, color temperature is the expression of energy levels of light sources in kelvins, based on the notion of a perfect absorber which changes color dependent on the temperature it is heated to. That's why color temperature of light measured in Kelvin. Selection criteria of luminaire based on CRI as per Indian Standard 3646, Part 2, Table 4. Here in the table you can see the recommended value of color rendering index for the category of warm, intermediate and cold fixtures. Application of color rendering in between 20 to 40 is wherever rendering is of no importance at all and marked distortion of color is acceptable. For a range above CRI 40 but less than 60, those light fixtures can be used in where there is little significance of color rendering but marked distortion is not acceptable. For a range in between 60 to 80 CRI, those light fixtures can be used where moderate rendering is required. For a range above 80 CRI, those light fixtures are required in an application where color judgment is necessary, such as in malls, hospitals, server rooms, shops etc., where good rendering is required for reasons of appearance. Guys, now you are aware of the most of terminologies used in the lighting design. More terminologies and method of lighting calculations will be explained in the next part. Don't forget to watch the part 2 to complete your learning. In part 2 you will be able to learn the uniformity factor, maintenance factor, utilization factor, light loss factor, how many lights, and what will be the arrangement of light to be considered to obtain the desired lux level of a room can be achieved, and what should be the recommended height of the fixture, what should be the room index. All these questions will be answered in the part 2 of indoor lighting. See you again on Gyan Guru channel with more interesting and knowledgeable videos.
Subscribe now and press the bell icon. Never miss an update.